Years ago, we used a lot of energy in the form of electricity to make light to be able to see. 30% of the electricity schools used was for lighting, and homes used about 14% of their electricity consumption for lighting. That's because homes, schools, and other commercial buildings used a lot of incandescent lighting. These inefficient bulbs were perfected by Thomas Edison in 1879 and didn't change much for the next 125 or more years. These bulbs were surprisingly inefficient, converting up to 90% of the electricity they consumed into heat, not light. Notice how not only does the bulb quickly heat up, the air around it seems to heat up. As the electrons pass through the filament, it superheats the metal, creating light. The resistance in the filament acts like friction against those electrons. The Energy Independence and Security Act of 2007 changed the standards for the efficiency of light bulbs used most often. As of 2014, most general use bulbs must be 30% more efficient than traditional, inefficient incandescent bulbs. What do the new standards mean for consumers? The purpose of the new efficiency standards is to give people the same amount of light by using less energy. This matches our definition of efficiency, which aims to do the same amount with less energy. Advancements in technology mean that we can see the same amount of light but not use as much power. We're using less energy over time. Most incandescent light bulbs have since been phased out and are no longer available for sale. This has resulted in significant energy savings for homes and schools. Newer, efficient lighting now accounts for 11% of the electricity used in schools, but only 5% used in homes. There are several lighting choices on the market that meet the new efficiency standards. Compact fluorescent light bulbs, CFLs for short, provide the same amount of light as incandescent bulbs, but use up to 75% less energy and last 10 times longer. CFLs produce very little heat. The bulb itself warms up, but the air around it doesn't heat up. The infrared camera is picking up thermal energy from the current that passes through the tube. Using CFLs can help cut lighting costs and reduce environmental impacts. CFL bulbs fit almost any socket, produce a warm glow, and unlike earlier models, no longer flicker and dim. CFLs have a small amount of mercury inside and should always be recycled rather than thrown away. Many retailers will recycle the CFLs for you for free. Light-emitting diodes, better known as LEDs, are gaining in popularity. Once used mainly for exit signs and power on-off indicators, improved technology and lower prices are enabling LEDs to be used in place of incandescents and CFLs. LEDs are one of the most energy-efficient lighting choices available today. LEDs use 75% less energy than traditional incandescents and have an average lifespan of at least 25,000 hours. The cost of LEDs has dropped in the last 5 years and may continue to drop. They use less energy than CFLs, save more electricity, and produce fewer carbon dioxide emissions. One LED bulb has several tiny LEDs inside of it. LEDs contain semiconductors like solar panels and other diodes. However, the difference is in the way the electrical energy is used by the LED. The U.S. Department of Energy estimates that widespread adoption of LED lighting by 2027 would reduce lighting electricity demand by 33%. This would avoid construction of about 40 new power plants. Thanks to ongoing technological innovations, light bulbs keep becoming more and more efficient. They're able to produce the same amount of light with less energy. A better light bulb is only effective if people use them. Conservation is the behavioral choice to use less energy. You can choose to conserve energy by installing more efficient light bulbs. To help make that choice, let's compare different styles of light bulbs on an even playing field. Using this worksheet, we can compare the total cost and environmental impact of 4 different types of light bulbs. To compare each light bulb, we'll need to calculate the cost of electricity, its life cycle cost, and the environmental impact. For each step, we'll be using different given information for each light bulb. We'll be calculating using the same steps. We're going to assume that each type of light bulb is going to run for 25,000 hours. We know that incandescent bulbs only last for about 1,000 hours. So that means we're going to require 25 bulbs. So we take the number of hours, 25,000 total, divided by the bulb's lifespan, and that's why we know it takes 25 bulbs to meet that quota. Once you know how many bulbs are required, you can find the cost of the bulbs alone. We have 25 light bulbs, they're 50 cents each, so I'm going to take 50 cents times 25 bulbs, and that's going to give me $12.50. This is the cost of the light bulbs alone for 25,000 hours. The real cost comes in with the electricity. We need to find our electricity consumption. We're calculating 25,000 hours of usage times the wattage of our light bulb in kilowatts. Now this is a 60-watt light bulb. It uses 60 watts of power, or 0.06 kilowatts. I need to use kilowatts because kilowatt hours is the unit that we sell electricity in. I'm going to take that, and that'll give me 1,500 kilowatt hours. That is my total consumption. You can think of this as buying gallons of gas. You're using a total amount of electricity to power the light bulbs for a certain amount of time. Just like you pay per gallon, you pay 0.129 or about 13 cents, depending on where you are, per kilowatt hour. So consumption in this case is 1,500 kilowatt hours times 0.129 cents. I'm going to multiply those together to figure out how much it costs to light these light bulbs for 25,000 hours. It's a total of $193.50. When incandescent bulbs were more popular, the cheap bulb made it a lot more enticing. People didn't think about the fact that they were spending more than 10 times that on just the energy alone. When we look at the total life cycle cost, we need to account for the cost of the actual bulbs, in this case $12.50, and the cost of the electricity for the life cycle of 25,000 hours worth of light, $193.50. We found these two pieces of information earlier. We're just putting them together. So that means the total life cycle cost of this light bulb, or these 25 light bulbs providing 25,000 hours worth of light, is $206. Again, relatively cheap purchase, but over the course of 25,000 hours, they use a lot of electricity, and you have to replace them quite often. These inefficient bulbs were inefficiently priced as well, but people didn't look at the real cost of using these electronics. We then can look at the environmental impact beyond our own pocket. This is based on how much energy we use. Just like the amount of gasoline you use in a single gallon of gas has a calculatable carbon footprint. We can do the same thing here. Every kilowatt hour consumed is 1.6 pounds. So 1.6 pounds of carbon per kilowatt hour. So we know that it was 1,500 kilowatt hours. So we multiply that by that constant of 1.6 pounds. It's almost like a cost you pay per gallon at the gas station. Here you're paying in the amount of carbon that you're potentially releasing in the production of the electricity used by the light bulb. We get, in this case, 2,400 pounds of carbon dioxide. So not only were these light bulbs inefficient, they were costly, and they put out and used a lot of carbon. Anything that uses a lot more electricity uses a lot more coal, a lot more natural gas. It brings a lot more of that carbon up from that lithosphere, releasing it into our atmosphere and creating notable climate change. Compare the costs and environmental impact of other light bulbs to see which is more efficient and which makes a bigger impact in your pocket and in our environment.